Today we'll learn the basic theory of covalent bonding, that is valence bond theory or VBT. It was introduced by the chemist Linus Pauling. Pauling has got Peace Prize, Nobel Peace Prize, as well as the Nobel Prize for its basic theory of covalent bonding, valence bond theory. This theory explains the hybridization of the covalent molecules, not only covalent as well as the coordinate salt type of the molecules on compounds. Hybridization is the process of intermixing and recasting of atomic orbitals. Atomic orbitals of combining atoms in the molecules get hybridized to various forms of hybridization such as sp hybridization, sp2, sp3, then d orbital if involved, that is dsp2, dsp3, d2sp3 or sp3d2, same hybridization, and d3sp3 hybridization. So when sp orbitals of the atoms, combining atoms in the molecules, covalent and coordinate molecules, get overlaps are ss, sp, pp overlaps, or dsp involving d orbitals, dsp overlaps, dsp2, dsp3, d2sp3, d3sp3. Such a variety of the hybridizations are present in the covalent and coordinate molecules. If sp hybridization is there, linear shapes are shown by the molecules. Simple molecules like BeCl2 having bond angle 180 degree, beryllium at the center, fluorine at the side atoms. sp2 hybridization having plain triangular structures. Plain triangular structures are shown by the molecules, simple molecules as well as coordinate molecules, like double bonded compounds contains sp2 hybridization. Carbon carbon double bond also contains the sp2 hybridization. The triple bonds contains sp hybridization. Single bonded carbon atoms contains sp3 hybridization, tetrahedral structure. Here bond angle for triangular shapes are 120 degree, tetrahedral 109 degree. Standard bond angles are there. Tetrahedral molecules like methane are showing this type of the hybridization. Ammonia also with lone pair showing sp3 hybridization. The simple molecules are showing this hybridization. Complex also showing hybridizations. dsp2 hybridization have the planar structure. The dsp3 hybridization have tbp structure, trigonal bipyramidal structure like this. Trigon and bipyramids, upper and bottom pyramid is there. Planar structures are shown by the dsp2 hybridization, like molecules NiCO4 complex. TBP shown by the PCl5 like molecules. Due to sp3 hybridization is shown by the octahedral molecules, octahedral shapes like SF6 molecule, simple molecule, sulfur hexafluoride, or many complexes. Octahedral coordination complex shows due to sp3 or sp3 due to hybridization. Inner d or outer d orbital. D3sp3 hybridization is having PBB structure, pentagonal bipyramidal shape structure. Here bond angles are 90 degree for octahedral shapes. Here 120 degree, 90 degree. Planar contains 90 degree. PBP contains 72 and 90 degree bond angles. The example is IF7 molecule, interhalogen iodine heptafluoride, or some complexes shows D3sp3 hybridization. Means hybridization shapes, structures, bond angles, then geometries, the overlaps, SS, SP, PP, D overlaps are explained by the hybridization concept of Linus Pauling under the valence bond theory. The valence bond theory is useful not only for the explanation of these concepts of structure, geometry, bond angles of molecules, but also the overlaps of atoms in the molecules and how many electrons are present in the molecules. That also explained by the valence bond theory. Let us take an example, and with that example we can study the hybridization and VBT concept. Suppose NH3 molecule is to be formed. Nitrogen combines with 3 hydrogen, nitrogen atomic number 7, the configuration is 1s2, 2s2, 2p3. Means valence orbitals are there, hence theory is valence bond theory. Valence bonding theory means valence orbitals involved in the bonding. Covalent bonding, the molecule has shape like this: hydrogen, hydrogen, hydrogen at one side, and it contains one lone pair. We will see in this hybridization concept. And bonding, lone pair is present on nitrogen, free pair of electron. So here 2s orbital in the ground state. What is the postulate of this theory? Ground state of the atom is there, central atom is there. It goes hybridization and overlaps with side atomic orbitals. The overlaps are there and hybridization takes place. Here nitrogen has 3 electrons in p orbitals. 2s2 is there, 2p3 is there. So here what happens? These sp3 hybridization takes place. The valence orbital get hybridized as sp3, 1s 3p orbitals. Here 3 hydrogen atoms comes for bonding. After hybridization, each hydrogen has 1s1 electrons. So electrons of hydrogen combines with electrons of p orbitals of nitrogen, and the covalent bonds are formed by sharing of electrons. So in this way the ammonia is formed like this, NH3. And here s orbital lone pair remains on the nitrogen as a free lone pair. So sp3 hybridization in this molecule has a tetrahedral shape. The bond angle should be 109 degree, but due to this repulsion of lone pair on bond pairs, the bond angle become 107 degree 28 minutes. So that happens in the NH3 molecule. So distortion of the bond angles and shapes also explained by the valence bond theory. So it is very useful theory for covalent molecules and coordinate molecules.